business world is under increasing pressure to transition to renewable energy use for operations and practices in order to reduce carbon emissions and contribute to a net zero economy in the face of the current environmental crisis. However, the ability of companies to commit to a sustainable future is impacted by both external and internal factors. In the next half hour, Executive Television explores different perspectives on the challenges and solutions of a green approach in relation to renewable energy, with analysis from 3 companies operating in different sectors that are embracing an environmentally conscious attitude.
Orkney is in prime position to really benefit the world. The abundance of energy, particularly wind, that we have in and around these islands could have significant benefit for the world. And we are really up for supporting that transition from the black economy to the green economy. We have the unique geography to do it. We have the determination to support whoever comes to do it. And I think we are on the threshold of something quite extraordinary.
The biggest challenge of decarbonising the future of the islands is working out how we're going to achieve that. If we go for electricity, we've got plenty of wind, we've got plenty of tide, and that's fine, but it's how you store the excess energy and transmit it. If you're replacing oil and you're replacing gas, it's what you replace it with, because the calorific value needs to be sufficient to be able to transport sufficient quantities. Certainly we'll be able to provide hydrogen, and we can certainly do that now in creating hydrogen on the islands. But in the marine side, that doesn't give you enough bangs for buck to be able to propel a large merchant ship through the water. So for the oil tankers that we come in, needs to be something much more powerful to be able to provide the motive power for that. And at the moment, it's unsure as what that might be. The other difficulty is with the age of the vessels, you need something that can be retrofitted easily into vessels to be able to decarbonise them. Because of the larger vessels, the engine sizes are so large that you're not necessarily going to be able to replace them easily. So it's how you achieve that. And that's something we're very much looking forward in the Harbour Authority, but also in Orkney itself, is how do we go around and tackle that challenge and provide something that can decarbonise what already exists to get to where we need to be in the future sooner.
When you're looking at the costs of electricity, most people consider what's the price of the electricity. So what's the price per megawatt hour from a wind farm or from a power station? That's only a fraction of the challenge. And in fact, the price of electricity forms less than half of what you're charged in any given bill. All the rest is about running the grid, balancing the grid, keeping the stability and all that sort of thing. And those costs are going up exponentially. We're not addressing them as we need to in an integrated manner. At the moment, we are addressing each individual aspect of the problem in isolation, when they've got to be addressed in an integrated manner. We're ending up with an immensely complex system that, like any centrally planned economy, you cannot plan for everything, and there is always scope for disaster. That's why we had the blackouts in 2019. That's why we have more than half a dozen very near misses for blackouts throughout the UK every single year. And in fact, they're growing in number and severity, despite all the additional costs.
We started out with the principle that renewable energy should be the future energy supply for the world. And our vision still to this day is a world powered by renewable energy. And what we want to see is that renewable energy replaces fossil fuels over a just transition, and that creates a modern society without compromise for consumers, without compromise for lifestyle, but saving the planet at the same time. We are in a state now where most governments around the world have a target to get to net zero, and that net zero target can only be achieved by deploying renewables. So the investment that is lined up for this sector in the next 10 to 20 years is just staggering, and we wish to help our clients make the most of that process and to deliver cheap renewable energy for consumers, because renewable energy will be the thing that effectively runs economies in the future. When you embark on a renewable energy project, you're obviously starting with, in most cases, a bare bit of sea, a bare bit of land, or whatever. So the initial challenge is to make sure that the land is secured for the client, that the environmental impact assessment allows you to get the permitting for the site, whether that be solar, onshore wind or offshore wind. That then leads on to the next challenges, which are effectively establishing the grid connection for that project and the availability and the timeline for that grid. And then the final issue is maximising the technology and the supply chain for that project to give the cheapest possible outcome.
Offshore wind we're seeing huge growth and capacity increases, 36 gigawatts of additional capacity in the pipeline for the UK in the next 12 months. That's the next 12-month pipeline, which is second only to China globally. So the UK is really leading as a renewable nation.
Utilising renewable energy sources has several benefits for businesses, including the apparent reduction of carbon emissions, but also marketing and PR opportunities, reduced energy costs, and even additional revenue streams. However, environmental concerns should not be ignored when using these sources. There are many different ways businesses can utilise renewable energy. Depending on the scale of these systems and energy use of the business, companies can also produce, store, and export energy that is generated, as well as protecting themselves from future fluctuating energy prices. Hydrogen enables businesses to fully utilise renewable energy, as it is generated through renewable energy processes and used as a zero-carbon emitting replacement for fossil fuels. Hydrogen is easily stored as either a gas or a liquid and can be exported using existing gas pipelines.
We've got to actually go and build our big battery and show the world that what no one's ever done is build a battery that's so big that it backs up a country using renewable energy. As far as the UK is concerned, we think the UK could be completely energy independent. It's an island at the end of the day. We looked at high temperature electrolysis because what we knew that we had a lot of waste heat coming out of when you're just releasing it to the atmosphere otherwise when you're compressing air into a salt cavern. So it was a very easy solution. We thought if you use that waste heat to heat up water in the electrolysis process, and it makes the whole production of hydrogen a lot more efficient. We call it the hydrogen patent. We think it could be really valuable. I mean, all our lawyers have said this could be very valuable, and especially in the future when people are starting to look at this now. We went to a patent lawyer and said, is this patentable? And he said, yeah. I said, that's quite high level, isn't it? Yeah, it is, but no one's thought of that. You're basically putting two technologies together. You put in compressed air together with hydrogen.
Another way of looking at the energy transition is today's energy system is effectively a gas grid, an electricity grid, and transportation and such like. Well, what are our technologies? We're looking at electricity storage to support the electricity system. We're looking at hydrogen to support the gas system and its conversion. And between the two of them, they support the transportation system. So it's effectively addressing the biggest issues of the energy transition and in addressing them in a truly integrated way. And the hydrogen technologies that we offer and the electricity storage technology we offer are actually mutually complementary. They support each other. One without the other can't do the job. Both together can.
With my international contacts and network, for example, in North Africa, in a country such as Morocco, here we have the ideal geology for caverns to contain both compressed air and or hydrogen. Within that, we also have the solar input there to produce, for example, green hydrogen. Within that, we'd also have to look at mid-level energy storage to ensure the electrolyzers can be running 24 hours. And then on top of that, there is a process of actually going to it using the network.
Net zero targets can be met if everybody sticks to what they've signed up to. The issue is with things like the war in Ukraine, the oil and gas price spike, and COVID, you create real difficulties for the political system, which generally has a 5-year cycle, and when we have to be concentrating on a 30-year investment program. This requires very mature politics and requires a really strong will to deliver. So the biggest hurdle is that political will in the longer term to actually deliver and to see poorer countries and less developed countries through their transitions, as well as us in the more developed world developing our transitions. And that way we will get there.
There's a huge understanding that renewables are a benefit in Orkney. All our electricity came from renewables by 2013. In fact, we can produce more electricity than we can use and more than we can export. So since we've come to that point, so many local people took forward their own renewable device. They saw this as being a benefit because our resource, wind, wave, tide around these islands is so significant. And people know that it makes sense to generate where there's an abundance of energy. So converting that from being a problem to us to being an enabler is a huge step forward. So in many ways, our population have embraced this like none other.
The opportunities that are now going to be supplied by both ScotWind and some of the other rounds of offshore wind developments are probably unique for a place like Orkney. So the whole of the offshore wind sector has to come together, including ports, to be able to drive forward the plans of the governments to hit those decarbonisation and net zero targets. And it's a big challenge. Wave and tidal are still there. Wave and tidal are still very important. There's still now a step change going up, particularly in the tidal energy sector, of testing the next generation of generators in our waters. That then was hoped to get to a commercial market, and again, the master plan supports that. The development at the Hatston Pier Orkney Logistics Base will provide a laydown area and support for operations and maintenance of not just offshore wind, but also tidal energy. So that's a wide-ranging sort of success that we can provide, and all of it will be in the renewables and green energy sectors.
It is important to remember that not all renewable sources are economically feasible and require significant development before becoming widely used by businesses globally. Implementation of processes to utilize renewable energy sources requires significant investment in technical and physical operations. Government regulation also has a significant impact on businesses' ability to adopt processes utilizing renewable energy. Despite its public commitment to a net zero future, there has been some concern as to whether they are supporting businesses adequately and whether increased regulations or red tape are hindering businesses' ability to embrace renewable energy.
So we can optimize solar and wind energy, and we do that by first of all being able to time shift that intermittent energy and make it dispatchable, so we can then offer it whenever it's required. But the additional thing that we can then do is that once that energy is stored, we can use it in multiple ways. For example, we can offer that energy on the wholesale market, we can offer that on the balancing market, we can offer that for ancillary services, and there's probably about 18 to 20 different ancillary services that we can offer it for. And by co-locating it, we can also reduce the infrastructure costs for both solar and for wind. So that enables the UK to become energy independent, and actually this can be done today because the underground storage that we need to be able to achieve that is available today. But this is not just an issue for the UK. We've appraised that 60 to 70 countries around the world have the right underground geology to be able to store electrics technology. So we can do that globally.
The renewable energy industry is seeing unstoppable momentum right now, driven by the global need to decarbonise and address climate change. You've seen over the last 12 months the UK and Scottish governments collaborating to deliver significant additional renewable capacity through the ScotWind process, licensing process, and the round 4 licensing process as well. So both together adding about 36 gigawatts of additional offshore capacity. So it's not just offshore, but that's where the predominant delivery of extra renewable energy is going to come from. Most of it in Scotland, by the way. I think we're really well placed as Natural Power to take advantage of these market developments and support the winners of those contract for difference competitions and the winners of those licensing applications get their projects up and delivered.
Innovative emerging technologies can help provide businesses with effective solutions to challenges associated with renewable energy transition and utilization. As the increasing research and development are focused on the renewable energy sector, innovative technology can play a key role in ensuring renewable energy transition can become more feasible and efficient for businesses. In the age of the digital society, innovative technologies are becoming integral to all businesses' operations, and therefore development is at the forefront of innovation in the majority of sectors. It's important that organizations in the same or similar sectors, along with the scientific community, cooperate and communicate in relation to technological advancements associated with renewable energy transition and generation to benefit the environment as a whole.
Data analysis is critical to a project's development for several reasons. Firstly, you can assess either the solar availability or the wind's availability on any given site. Once you understand its availability, you can design the technology around the constraints on that site to maximize the output from that site. Therefore, critical to getting the maximum output. Data enables you, when you're operating the project, to understand how the project is operating, how it's maximizing its output, and to predict when there's going to be failure on a site, such as a gearbox in a wind turbine. Predict that failure before it happens so you can repair the gearbox before it fails. So data can enable us to have a much better and more efficient output from the wind farm and reduce the amount of downtime on that wind farm, therefore increasing the client's return on its investment. Energy security can be established in a number of ways going forward. Firstly, I would say there needs to be a just transition from the oil and gas world we know today and the energy world we know today to a predominantly dominated renewable energy future. Now, in that transition, the way we get security of supply is by redesigning the regulatory system over time, by developing things like green hydrogen over time, increasing and improving our batteries and the long-term battery storage that we need, and by also vitally making sure homes are as energy efficient as possible and that new heating systems are electrically based and renewable based. If we do all of these things, then we will have a secure energy future.
I think a lot's got to do with the fact that we've seen innovation in these islands over the years, whether it was from the Navy being here or some of the things that happened way in the past, whether it was through early adoption of the oil industry. It's just something in islanders' ability to work together, to support each other, and actually to make sure that anybody gets the help they require to see if something works. So we've got a can-do attitude, we've got a will-do attitude, and we are certainly up for supporting anyone who comes onto our islands to try something new.
So Storelectric is in the area of energy storage. That's hundreds of megawatts to gigawatts. That's gigawatt hours, potentially up to terawatt hours. But we're also in the midst of a series of technology developments that I believe will have a profound effect on all of our lives. And these include such things as ESG, climate tech, green energy, renewable energy, hydrogen and the hydrogen economy, large-scale storage, AI, the Internet of Things. And it's the company that can really combine these offerings together into value-added offerings that the market needs that's really going to make it big, not just today, but also in the future, 10, 15, 20 years from now. And Storelectric, I believe, we address a number of these converging technologies. We are ESG compliant. We're in the area of renewable energy. We're in the area of green energy, climate tech, hydrogen, storage. And this is not a coincidence. This is a strategy on the side of Storelectric to be in the midst of these converging technologies, these developmental technologies that we think will enable us not only to make it big today, but to make it big tomorrow.
Although it's important for businesses to cooperate on advancements in the renewable energy transition process, the different aspects of individual companies will determine the effectiveness of the transition and utilization. These aspects include the scale of operations, the specific product or service offered, the scale of demand, and management objectives and principles. Therefore, it's important for a business to invest in its own research and development in order to contribute to the innovation of renewable energy processes. Businesses can differentiate themselves with innovative adaptations of emerging technologies to successfully transition and utilize renewable energy in relation to their organizational processes and objectives.
If you're on an island, you're always at a slight disadvantage. So everything you do has got to be good if it's going to be exported. You've also got to promote yourselves really well so that people will take that extra step and come to what you've got. And in the last number of years, particularly in research and innovation, Orkney has excelled. We've had a long history of doing things and finding new ways to make things work. And there's a very interesting place because island communities collaborate very well. And so many people in this community have formed alliances and they support each other to get better results. And nothing could be more true than what has happened in our long look into the renewable industry. We've been at it, way back since the 1980s when we had the first, grid-connected large wind turbine. And since then, we have embraced this change and developed so many things. Some things haven't worked, other things have been particularly successful. But we know that by working together, we get a much better result.
Certainly one of the central tenets of the natural power culture is being a pioneer in the industry, and we permitted the first offshore wind installation in Scotland, and we've developed from that, and certainly that innovative approach to technology has meant that we've developed all sorts of clever, unique skills and tools and approaches at natural power. We have a control centre here that we're developing into a 24-hour performance centre that enables our clients to optimise their renewable energy assets using data and all sorts of clever monitoring and mathematical modelling to improve asset efficiency. So really clever and innovative approach to the industry.
As an analogy, if you think of batteries as being a pistol, we're the artillery. It's a difference in scale and duration of factors of hundreds or thousands even. So it addresses a totally different part of the problem. But then there's a question of efficiency. Our adiabatic case is about 70% efficient, grid-to-grid, lifetime average, which is more efficient than batteries. When I say that, most people hold up their hands and say, no, batteries are far more efficient than that. Yes, they claim 85 to 92% efficient. But you've got to look beyond that and see what's underneath that claim. First of all, their claim is terminal to terminal. Our claim is grid to grid. The two main differences being power conversion, AC to DC to AC again, which is about a 5% penalty, and cooling, which in temperate climates like Britain's is about 10% penalty and much higher in hotter countries. And the second issue is that they quote their efficiencies on day one. By the time of swap out of the cells, which is 8 to 10 years later, incidentally our plants last 5 times as long, by the time of swap out of cells, both of those inefficiencies are roughly tripled. So not only do you have to consider that the lifetime average efficiency grid to grid is about 30% below what they're claiming, but also you've got to manage a very rapidly deteriorating facility.
So we can anticipate that the need for storing energy is going to increase in the UK because we're moving from very reliable combustion of oil or gas, where we can control how much we burn and how much energy we generate, through to more renewable and variable generation of energy from wind power or from solar power. It's estimated that the demand for energy storage at the moment from wasted wind power electricity is worth about £300 million a year. But looking forward into the increasing use of wind power, to generate electricity. Some estimates place that there will be a £3 billion market in the UK by 2050. So this is a technology which is going to be essential and get bigger and more essential as we go forward.
We've got a really good team, good advisory team of engineers, and the whole market is coming our way. Now you might ask what have we done in the last 10 years? We have done a lot, but I think we're probably a bit ahead of our time, to be honest. And the market is coming so fast our way now.
With the crucial role innovative technologies play in the renewable energy transition and operational processes, organisations must ensure their workforce has an up-to-date awareness of the changing and emerging technologies with the renewable energy sector. With the labour shortage many industries are currently experiencing, it's important for businesses to provide effective on-the-job training and development programs to their employees. Innovative digital technology can also enable businesses with the resources to upskill staff through e-learning programs, whether developed by the organisation themselves or adopting an existing program.
I think new jobs will predominantly be home-based and going forward that way, but a much more supportive and collaborative form. There's still a need for the heavy engineering, the manual-based jobs because of the size of equipment that we use and require. But certainly the supporting jobs are going to be much better home-based, much more flexible around people and how they want to be. But the traditional jobs will still remain because of the size of equipment we have and use and operate it every day. So the opportunities in the marine sector, so if you want to go to sea, there's engineering opportunities there's deck opportunities, getting the ships from A to B. And then it's all the supporting structure for that. So the maintenance services on the side, working with ports and harbours, creating the transport to and from ports and harbours and getting the logistics trail in, but supporting it with the paperwork, the licensing, environmental work as we do here, so environmental scientists monitoring what we do to make sure that we don't harm the environment, we keep ourselves as green as possible.
Over the coming years, the sector is likely to develop in numerous different ways. You're going to see an explosion in large grid infrastructure, joining up Europe with the UK, joining up the different grids in the US. Wherever you go, you're going to see large grid investments to help load shift, to help manage the system. You're also going to see a big change in the way we manage and regulate our systems, because we're going to have intelligent systems that help people in their day-to-day lives and help, but at the same time help manage energy. So the future for the sector is very exciting, and a lot of the stuff that people will experience they won't ever see. It'll just happen behind the scenes, and that's the best way for things to happen.
Store Electric has a unique set of technologies linked with the business model and the right people to really be able to grow the business. Store Electric is engaged in the global energy transition and has some exciting opportunities to provide bridging solutions to help the world move from conventional power generation to the new hydrogen economy.
As the UK government, along with many other countries, targets a net zero economy by 2050, the impetus will be put on businesses to develop sustainable and non-carbon emitting operations and practices. Renewable energy may provide the solution for this development, although the challenges associated with transition and utilisation must not be underestimated. Innovative, emerging technologies will play a crucial role in enabling businesses to overcome these challenges. However, the efficiency and continued development of these technologies rely on effective research and development, as well as the expertise of the individuals responsible for their innovation and implementation.